Welcome to AP Statistics. Today, we are diving into topic 1.11, random sampling. Our objectives are, first, to identify different sampling methods, and second, to justify the appropriateness of a sampling method. By the end of this lesson, you will be able to distinguish between simple random, stratified cluster, and systematic sampling, and explain when to use each one. Random sampling is the gold standard in statistics because it helps eliminate bias, allowing us to generalize our findings from a small group to a much larger population. Before we look at specific sampling designs, we need to understand the two fundamental ways we can pull individuals from a group. First, let's look at the difference between sampling with replacement and sampling without replacement. Imagine we have a population of 5 colored balls in a box. In sampling without replacement, an individual can be selected only once. Once we pick the red ball, it stays out of the box. The population size decreases for the next pick, and there is zero chance of picking that red ball again. In most real-world human surveys, we sample without replacement. In sampling with replacement, the individual is returned to the population before the next selection. This means it is possible to select the exact same person or object multiple times. While less common in field studies, this is a vital concept for probability and certain computer simulations. So, the key difference is whether the unit goes back into the pool or stays out. Now, let's discuss the most fundamental random sampling technique, the simple random sample, often abbreviated as SRS. In a simple random sample of size n, every possible group of size n has the same chance of being selected. It is not enough for just the individuals to have an equal chance, the groups must as well. Think of it like a fair lottery. There are several ways to conduct an SRS. You could write everyone's name on equal-sized slips of paper, put them in a hat, mix them thoroughly, and draw them out. Alternatively, you can assign every individual a number and use a random number generator on a calculator or computer to pick your sample. For example, if we are selecting 3 students from a group of 10, we assign numbers and then generate our random set, like 04, 07, and 02. Because every combination is equally likely, an SRS helps ensure the sample is representative of the population without any intentional or unintentional favoritism. Sometimes we want to ensure that specific groups within a population are represented fairly. This is where a stratified random sample comes in. In this method, we divide the entire population into non-overlapping groups called strata. The key is that these strata are homogeneous, meaning the individuals within each group share a specific characteristic, like grade level, gender, or income bracket. To form the sample, we perform a separate simple random sample within every single stratum, and then combine those individuals to form our final group. For example, if you want to know how students feel about school lunch, you might stratify by grade level, to ensure you get exactly 10 seniors, 10 freshmen, and so on. This method is more appropriate than a simple random sample when you expect the different groups to have different opinions, and you want to make sure no group is left out by the luck of the draw. A common point of confusion is the difference between a stratified sample and our next method, cluster random sampling. While they both involve groups, the process is very different. In a cluster sample, we divide the population into smaller groups called clusters. Unlike strata, which are groups of similar people, a cluster should ideally be a mini version of the whole population, containing all kinds of different individuals. The process works like this. First, you pick a few clusters at random using an SRS. Then, you collect data from every single person inside those selected clusters. Think of an apartment complex with 10 identical buildings. Each building is a cluster. Instead of visiting all 10 buildings, you randomly pick 2 buildings and talk to everyone inside. Cluster sampling is most appropriate when it is too expensive or difficult to travel to every individual in a population. It is a matter of efficiency. Just remember, in stratified sampling, you take some people from all groups. In cluster sampling, you take all people from some groups. Our final common method is systematic random sampling. This is a very structured way to pick participants from a list or a physical line. A systematic random sample selects members from a population according to a random starting point and a fixed periodic interval. Think of it like an assembly line. First, you must pick a random starting point. This is crucial. If you don't start randomly, the whole process isn't truly a random sample. After that, you pick every 10th or every 100th person that passes by. For example, if you are at a stadium, you might randomly choose to start with the third person through the gate, and then interview every 50th person after that. In this visual, let's say we pick every 5th person. This method is highly appropriate when you don't have a master list of everyone in the population beforehand, but you have a way to count them as they arrive or appear in a list. We've now covered all the major random sampling methods. Remember, the best method depends entirely on the situation. Use stratified to ensure subgroup representation, cluster to save on logistics, and systematic for ease of implementation on a moving population.